Now we will see lesson 44. In the last class we had seen that the electrolytic process. So in case of the electrolytic process, we had taken an electrolytic tank, and within this tank we had taken two electrodes, and two electrodes are called cathode and anode. Anode is the positive electrode and cathode is the negative electrode. When electric current passed into the electrolytic tank, electrolyte dissociate into cations and anions. Cation is negative, anion is positive. Cations moves to the cathode and anions moves towards cation moves towards the cathode and anion moves towards the anode. Here cation is positive ions and cathode is negative electrode. The positive cation moves to the opposite cathode, opposite charge electrode, that is cathode, and anion is negative ions that moves towards the anode, and anode is the positive electrodes. So positive electrode attracted to the anions and negative electrode attracted to the cations. This is the overall process of the electrolysis. So in previous class we studied, that is, we have taken a electrolytic vessel, and electrolytic vessels, what happens, we have taken two electrodes, that is anode and another is cathode, and this aqueous solution is called electrolyte. This aqueous solution was electrolyte. After passing of the electric current through the electrode, the electrolyte dissociates into positive charge and negative charge. This is the cation, these are the anions. So cations moves to the anode, and anions moves towards the cation moves towards the cathode and anions moves towards the anodes. So another important point of the process is that electric current during the electrolytic process passed into the, we have not right to past, electric current during the electrolytic process enter into the electrolyte through the anode and leave the electrolyte through the cathode. That means, suppose here is electrolytic tank. Suppose this is one electrode and this is another electrode. These are the metal plates. Suppose these electrodes were dipped into the electrolyte. Suppose this is electrolyte and this is the anode, and suppose this is cathode. And suppose this, as it is anode, so it's connected to positive pole of the battery, this is negative pole of battery. That means here it is written electric current during the electrolytic process enter into the electrolyte. So electric current from the battery when entered into the electrolyte kaha madhyamare asibo, it entered into the electrolyte through the anode. So anode bata asibo electrolyte ku pasila. So electric current from the battery anode ku aila, anode dwara electrolyte ku pasibo, electrolyte ru कोउटी की जीवो कैथोड को जीवो, कैथोड उपनु बाहरी की पड़ाइबो. So it is, so here it is written, so electric current enter into the electrolyte through the anode and leave the electrolyte. त माने electrolyte को छाड़ी की जाए कहा द्वारा ना कैथोड दे की पड़ा. This is the concept of the electrolytic process. Okay. So now we will see some examples of the electrolysis. First example, we will see the examples, that is electrolysis of aqueous NaCl solutions. Electrolysis of aqueous NaCl solution using platinum electrode. Suppose this is a container, electrolytic vessel, that means electrolytic vessels, and here I have taken two electrode, that is one is cathode, another is anode, and these two electrodes were made by the platinum electrode. Suppose this is anode, platinum electrode anode, positive electrode, and suppose this is cathode, this is also made by the platinum, negative electrode, and these two electrodes were dipped into the NaCl electrolyte, and this is the electrolyte, that is NaCl, aqueous NaCl. That means we are doing here what? Now electrolysis of an aqueous NaCl solution using platinum electrode. ता माने electrolytic vessel रे आमे electrolyte कहा को नहीं चु ना NaCl को नहीं चु एवं इलेक्ट्रोड कहा को नहीं चु ना प्लाटिनम को इलेक्ट्रोड हिसाब से नहीं चु ताकू बैटरी द्वारा कनेक्शन कर चु जेटा पॉजिटिव पोल को कनेक्टेड हला एनोड को आगला जे नेगेटिव पोल संगे रे बैटरी रो नेगेटिव पोल संगे रे अटैच करा गला कैथोड को आगला. दिस इज एनोड, दिस इज कैथोड. सो एते बोले करंट पास होबो during the process of electrolysis. What will be happens? NaCl after passing of the what? Electric current. NaCl is the electrolyte here. So NaCl dissociate into Na plus Cl minus, and also is this is aqueous solution. It also contain water. The water also dissociate into H plus OH minus. So between this is the two positive ions and these are the two negative ions. So between the Na plus and H plus, the H plus, that means H plus ion have lower discharge NaCl ion have a lower discharge potential. Hence, so NaCl ion between the Na plus and H plus ion, the H plus ion have a lower discharge potential. तामाने discharge सहज ही परिवो. ये discharge केमती ही परिवो. A कम potential, कम energy दरकार discharge होगा को. Charge होची discharge ही जीवो. माने गोटे electron gain करिवो. Hence, it move first towards the cathode এটা পজিটিভ চার্জটা তখন ক্যাথোড আর বুঝিব ক্যাথোড নেগেটিভ চার্জ similarly we can write between the OH minus and Cl minus ions. Cl minus ion have lower discharge potential, hence move fast towards the anode. So two processes will be carried out in anode and cathode. So at anode, what will be happen at anode? The Cl minus ion loses 1 electrons. Again this Cl plus another join with another Cl to form Cl2 gas. So Cl2 gas liberated মানে বাহারিবা. That means at anode what will be happen at anode Cl minus moves to the anode and loses 1 electrons. One Cl mixed with another Cl and to form Cl2 gas. So Cl2 gas liberated at anode. Similarly at cathode what will happens? H plus ions gain 1 electron to form H. 1 hydrogens at cathode H plus ion gaining 1 electron and form H. H hydrogen join with another hydrogen to form H2 gas. So H2 gas liberated at cathode. Okay, so hence we concluded that electrolysis of aqueous solutions. During the electrolysis process of aqueous solutions of NaCl by using platinum electrode, Cl2 gas liberated at anode and H2 gas liberated at cathode. This is the example 1. Similarly in example 2 we will see example 2, that is electrolysis of aqueous copper sulfate solution using platinum electrode. That means we have to take a electrolytic tank, and these two electrolytic tank, what happens? We have to take electrolytic solutions. Suppose this is the electrolyte. What we have taken? Electrolyte. We have taken copper sulfate solution as electrolyte. That means copper sulfate is taken as electrolyte. And this electrolyte we have dipped a electrode. This is called the anode because it connected to the positive pole of the battery anode, and this is called this electrode connected to the positive pole of battery, hence called anode. And this electrode connected to the negative pole of battery called cathode. These two electrodes were the platinum electrode. So this is platinum electrode. This is also platinum electrode. Okay. So during the process of electrolysis, what happens? So we get two reactions like, suppose copper sulfate we have taken. The copper sulfate dissociate into copper plus 2 plus SO4 minus 2. These electrolyte dissociate into their ions after passing of what? Electric current. The copper sulfate dissociate into Cu plus 2 plus SO4 minus 2. Similarly, H2 also dissociate into what? H plus plus OH minus. Okay, so we get 2 plus ion and 2 minus ion. So between, what happens between these 2 plus 2 ions, Cu plus 2 have lower distance potential and moves to, so Cu plus 2 moves to where? Cathode. And between these two anions, SO4 minus to OH minus will move fast toward the anode. So because why? Because it have lower distance potential between the SO4 minus 2 and OH minus 2. That means between these two anions, OH minus have lower distance potential, so move fast towards the anode. Okay. So two process, that is oxidation and reduction process, will be carried out in at two electrodes. So we can write here that at cathode, first we have to write at anode. At anode what happens? OH minus loses 1 electron, OH plus 1 electrons. Yes or no? Yes. So one OH mixed with another OH to form 2 OH. So at anode, what will happen? OH minus ion gives 1 electron to form OH. 1 OH mixed with another NOH to form 2 OH. This 2 OH gives what? That is give H2O plus oxygens. Here oxygen is not in balance form. Here 3 oxygen is present. Here 1 oxygen is present. So I have to balance it. Here 1 oxygen, half of O2, 1, 1, 2. Here 2 oxygen, 2 hydrogen, 2 hydrogens. So by balancing we got 4 OH tends to 2H2O plus O2. That means his O2 gas formed and liberated at anode. So hence this O2 gas formed during the process of electrolysis. This O2 gas released at the anode. So at anode, O2 gas is liberated. Similarly at cathode, what happens? At cathode, so these two electrons, what it is released in anode, that is gained by the copper. So copper plus 2 ions have lower distance potentials, and that will move fast between the H plus and Cu plus 2 ions. Cu plus 2 ion have lower distance potential, move faster towards the cathode and gain 2 electron to form copper, that is deposited at cathode. So electrolysis of aqueous copper sulfate using platinum electrode, we got O2 gas, oxygen gas liberated or released at anode and copper deposited at cathode.